the person will acquire velocity, the trolley will acquire velocity, then what is that UR? V1 minus V2. Minus of minus V2, it's like that. With respect to state of trolley different, with a velocity UR relative to trolley are different. Okay? State word brings, then you should think the way you are thinking. Fine?
Yes, sir.
In the end, I'll bring that problem because now you'll get confused. So therefore, I'm just let's focus first on one aspect, learn concept. Then in the end, we'll explore the other ideas. Okay, two persons are there. They're initially attached. Person A and B. That one they're standing at one end of the trolley. So first case, what will be the velocity of the trolley when they jump simultaneously, and when they jump one after the other? In which case, the momentum of the trolley will be more. That's what we are going to check. So the first situation will analyze. So when both the persons, they jump simultaneously. So let the trolley recoil with a velocity V1. So here both the persons are there. Both are having same mass. Let the velocity of the persons, let it be say some VA or something, anything you can write it. V dash, I'll write it. VP will write it, velocity of persons. So this is 3m. Then anything directed towards right, positive. So plus UR equal to velocity of person plus VP minus of minus V1. So what is velocity of person? It should be equal to UR plus V1. Now apply conservation of linear momentum. Initial momentum, net force is 0. Net force on the system along x-axis 0. Initial momentum 0. Final momentum 2m VP, mass of both the persons, minus 3m V1. VP is equal to UR plus V1. And this is negative sign, sorry. So again, what is V1 equal to? 2m UR by 2m plus 3m. UR by 5. Keep this. This is the first part of the problem. We have to compare again now in the
UR by 5.
2 UR by 5. 2 is missing. A second case, they jump one after the other. Is it okay? I think this is like a, you can directly write this V1, no? What is the mass of system ejected? 2m with what speed relative to trolley? UR by total mass of system. Directly you can write V1 equal to 2 UR by 5. In exams, you are supposed to do like this. And let's take now. They jump one after the other. There's a totally second situation. Totally a second situation. So initially, this is both the persons A and B, they are at rest. So first person A is going to jump now. Mass of 3m, this is 3m. So let the velocity acquired by this, let it be say some V1 we took it, no? So here VA, VB are the velocity of person. Let me write some symbol. VT1 I'll write it. So one person is here, other person he'll jump. So person A, person B will be there only. So velocity UR, let this be VA. Yeah, fine. Okay, now write the again conservation of directly can we write expression for VT1? No need to solve because already you are aware of this condition. What is the mass ejected? M. UR by total mass of system, m plus m into 3m. So this is UR by 5. Or what were the mathematics? UR is equal to VA minus VT1. Substituting that value of VA and solving. Okay, this one somebody are asking that how you got it. Okay, let me. What is the conservation of linear momentum? 0 is equal to MVA minus M plus 3M into VT1, velocity of the trolley. Okay, this I think directly you can write this one. Okay, now person B is going to make a jump. Look at now VT1, how VT1 is towards left. No, let's see what will happen. How is jumping now? Is jumping opposite to motion of trolley. No, so what do we expect? The speed must increase. Already we have just theoretically gave idea. So let's analyze here. Now this will be UR, velocity of person. Let it be VB. Velocity of trolley. Let me call V2 because I want to compare, or VT2. After second person making a jump. Then before and let's go for mathematics. UR plus UR equal to plus VB minus of minus V2. So UR minus VT2 equal to VB. That's the speed of the first person. So now initial momentum should be equal to final momentum. What is the initial momentum? Before person B jumping, what is the momentum of system? Minus of M plus 3M VT1 should be equal to minus of 3M VT2 plus M VB. Try to see this. Person B, before person B making a jump, person B and the trolley in what direction they are moving? They're moving towards left. This negative sign is very important here. Now let's substitute the value of VT1 and VB in this equation. Then we'll go for VT2. So after solving this, minus 4m, VT1 is UR by 5 equal to minus 3Vm VT2 plus M. VB will be UR minus VT2. Minus 4M UR minus MUR is equal to minus 4M VT2. So 4, this will be 9 UR by 20. Which will be greater? What we have to compare? We have to compare VT2 with V1 when they jump simultaneously, when they jump one after the other, in which case the momentum acquired is more.
Sir, VT2s.
VT2, it will be definitely VT2, it will be greater than V1. No? So what is the conclusion now? If a system, if it has to acquire more recoil speed, shall we eject total mass at a time or shall we eject the mass gradually? If we eject mass gradually, what happens? The system will acquire more recoil speed. And look at also here in this case, how the mass is ejected opposite to direction of motion, and compare VT2 and VT1. So is it VT2 greater than VT1? Yes, it is. So all these are conclusions. These are very important. VT2 greater than VT1. So therefore, if a mass ejected opposite to direction of motion, then what happened to speed of the opposite to direction of motion of the system? Then the speed of the system will increase. If the mass ejected in the direction of motion, the speed of system will decrease here. This is a major part of the conservation of linear momentum, what you are studying. Everyone I gave 1, 2 values, no, you have to check it. It's a compulsory, you have to work out once. Then a firm conclusion is needed. So how to make the system to acquire more speed? Shall we eject the total mass at a time, or shall we make the system to eject mass gradually? We should make the system to eject mass gradually so that it will acquire more relative speed. Okay, fine. This is these are the basics. They're not numericals. These are all some very important simplified things of the conservation of linear momentum. And you should never forget this, what I'm giving finally. All these numericals, what happen, they're helping you to conclude this one. Please do remember. So when you're going for exam, no, your background, this background must be there with you. Okay, you have to verify this. This is very important thing for the above problem. Okay, let's explore the other cases.